Okay, so here's a problem. Find the parametric equations of a line through point 4, -1, and 0 that is orthogonal to line 2. Line 2 goes through point 1, which would be -3, 9, and -2, and point 2, which is 5, -7, and -3. So first things first, what are we trying to find? Well, a line that's orthogonal. This means basically perpendicular. And so we will draw a picture basically to see what's going on here. Okay, so this is y. Just found out I've been drawing it incorrectly before. So x, y, and z. Now we have the point 4, -1, 0. So that's like that. I like to, draw it so I can see where it is in 3D space. Point 2 is in -3, 9, and -2. So here we go, somewhere about there. And point 5 is out here, about -7, so it's way out here, and -3, like so. So this line goes something like that, and we have a line here that goes something like that, probably. And that's perpendicular. So how are we going to solve this problem? Well, first we got to figure out what the equation is for this line. So to find an equation for a line, we'll divide this into two parts. Line 2. Find the equation for a line, we need a point. Well, we have points plenty. So I'll just pick point 1. That would be -3, 9, and -2. And we also need an a vector. Now, we can find the vector that goes through from point 1 to point 2, and we call that vector P1P. And the way we find that vector is it is head minus tail. Or, sorry, P1, P2. And that would be head, which would be P2, minus tail, which is P1. So that would be vector 5 minus a -3, so that would be 8. -7 minus 9, which would be -16. -3 minus a -2 would be -1. So here is our vector. So we can now define our equation for line 2. But we don't really need to actually write out the equation for line 2, because all we're really concerned about is this vector here. We need to find a line, we'll call this L1, because this has already been called L2. So line 1 is perpendicular to this a vector, and I'll keep a numbering system here so it's consistent. It's perpendicular to vector A2. Well, line 1 is parallel to vector A1, so A1 is perpendicular to A2. And how do we find perpendicular vectors? Well, we have a dot product equal to 0. So we can pick any vector for A1 that when dotted with A2 is equal to 0. Well, we could do, how about 2, 1, and 0? 2, 1, 0, when dotted with A2 is equal to 0. You can do the math on that. So now we have our vector, and we have a point up here. So we're ready to make our line. So I'll copy down this point for -1, 0. And a vector, I'll just copy this down so it's really clear. 2, 1, and 0. And we remember our line equation is three parametric equations. X is equal to the x coordinate of this point, so 4, plus the first part of the x component of the vector A times t. Y is equal to -1 plus t. And to be really explicit here, I'll just write in the zeros. Is equal to 0 plus 0t, where t is an element of the reals. Now, when you're actually doing this for a test or something, you don't need to put 0 plus 0t. Z is just equal to 0. So here is the answer to our problem. And I do have time for one more. So I'll just do a equation of a line that passes through 2 points. So we're given P1 is 3, 1, and -2. This is a new problem, by the way, so like so. New problem. P1 and P2 is -2, 7, and -4. So this I kind of did up top anyway, and this is we find the vector P1, P2, and this would be equal to -2 minus 3, so that would be -5. 7 minus 1, 6. -4 minus -2 is -2. So now we have this. This is a vector that goes through these 2 points. So we know that our line will be parallel to this vector. So we have a point as well. We'll just pick point 1. So we're ready to write our equation. So the line is x is equal to 3, that's this x component, minus 5t, and y is equal to 1 plus 6t, and z is -2 plus, minus 2t, where t is an element of the reals. And so you can see these problems can take the form of a really simple find a line between 2 points, or more complex, find a line that's perpendicular to another line that goes through a point. So that is a couple of line equations, and I'll see if I can do a video on planes in the next video.